Okay guys, this is Mr. Baker. I'm still figuring out how to use this video recorder. It's been about a year since I hooked this up. So while I'm playing with this, I'll let you laugh and get the awkwardness out here of me talking to you through video. My goal here is to do about 10 problems with you guys. Hopefully it'll take about a half hour, and then afterwards you can take a 10-question quiz on this. Okay, so the first problem we're going to look at is an absolute value problem. So if I told you to solve, let's say x minus 4, the absolute value of that being equal to 3. And we know that absolute value means the distance from 0 on a number line, and that we come up with two solutions when we do this. So to solve this, you set the x minus 4 equal to 3, and the x minus 4 equal to the negative version of what you had. And then we're going to go through and solve. So add 4 to both sides, giving you 7. And when you add 4 to the other side, giving you 1. Okay, for the next one, we're going to do an absolute value as well. We're going to add a little more to it. So let's say we have 2 times the absolute value of x minus 3 plus 5. Let's make this an inequality now, and we'll say it's less than or equal to 13. So your first step here is you want to get rid of this plus 5. So how do you undo an addition of 5? You'd subtract it from both sides. So this would give you 2 times the absolute value of x minus 3 is less than or equal to 8. Your next step is you'd want to divide both sides by 2. So x minus 3, the absolute value of that is less than or equal to 4. And now you're back to your absolute value being isolated. So we're going to say x minus 3 is less than or equal to 4. And when we go to do the other side, we want to set it to negative 4. But when we do the negative, and when we change it with an absolute value symbol, you want to flip the absolute value symbol. So we make it greater than or equal to, and go through and solve both of these now. So x would be less than or equal to 7, and x would be greater than or equal to negative 1. If you wanted to put this on a number line, say here's 0. What else are we looking for? We have a 7. And we have a negative 1, it's or equal to, so it's a closed dot on each of these. And where are we going? Greater than negative 1 and less than or equal to 7, and there would be the graph to your problem. Okay, the third one is going to be an inequality. So let's say we have y is greater than 3x minus 2. And we want to know what it would look like on an xy axis. So you want to look at this as a line. Just pretend you had 3x minus 2. And how do you graph that? This is your b value, if you were thinking of it as mx plus b. So I'm going to go down 2 units and make a dot. This is my slope, and slope is rise over run. So from here I'm going to go up 3 over 1 and make a dot. There's no or equal to sign here, so my line is a dotted line. If it was or equal to, then it would be a solid line. And now to do my shading, I say, what do I have here? It's greater than, and greater than makes us think up. So you would shade everything that is above the line. Okay, for the fourth one, we're going to look at domain, range, increase, and decrease. So let's just say that we have the following parabola, and this is at 2, and we'll say that's negative 1. And we want to talk about the domain, the range, the increase, and the decrease. So the domain is the left and the right, as this graph would keep going. So if we say this keeps going and going and going and going and going and going, the domain is what happens to the left and right as this keeps going. And as the x values keep going, this is just going to keep getting wider and wider and wider. So as far as the domain is concerned, we would say all real numbers or negative infinity to infinity. The range is the up and down part of the graph, and at its lowest point we're at negative 1. And as this keeps going, it's going to keep growing and growing and growing, but it's never going to go below negative 1. So we want to say that our y, which is our range, is greater than or equal to negative 1, and it would go up through infinity. The increase and the decrease is when we put our little guy on the line here, and as he starts running, where does he run from? He's run from negative infinity, and as he starts running from negative infinity, this graph goes down and it's decreasing, and it keeps doing so until he's run his way up to the number 2. So for my decrease, this graph is decreased from negative infinity to x to 2. And then when he's here at 2, this graph turns around and the function starts to increase now all the way up until he's run to what we would call infinity. So the increase would go from 2, x being bigger than that, to positive infinity. Okay, for our next one, we're going to talk about writing something in standard form. So if I showed you a graph here and we said, we'll make something up here. Let's say, here are your 3 zeros, and they're at -2, -4, and 3. So again, your zeros are where it crosses the x-axis. So you have a 0 at -4, -2, and at 3. So you can write that out here. Your zeros are -4, -2, and 3. And we want to write this in standard form. Well, if we want to write this in standard form, we're going to work backwards. So if my 0 is at -4, prior to us knowing that, we could have said we had the quantity of x plus 4. This would have been the quantity of x plus 2, and this would have been the quantity of x minus 3. To find these, you just subtract. You say x minus each value, and x minus -4 gives you a double negative. Same thing, and x minus 3 is written just like you see it. To write it in standard form, we're going to multiply each one of these out. So we just pick 2 of them, underline them, FOIL them out. First times first is x squared. We get -3x and a positive 2x. -3, positive 2 gives us a -x. And last times last, 2 times -3 is -6. I bring down my x plus 4. I'm going to take this x and distribute it through the whole quantity here. And then I'll take the 4 and do the same thing. When I run my x through here, I get x to the 3rd minus x squared minus 6x. When I run the 4 through here, it's plus 4x squared minus 4x minus 24. Combine like terms. There are no other x's to the 3rd power, so I can just bring that down. I have -x squared here, plus 4x squared here, negative, which is like saying 1x squared, even though you don't normally write that in. -x squared plus 4x squared is a plus 3x squared, minus 6x minus 4x, minus 6, take away another 4, gives us minus 10x, and then bring down our -24, and this would be your equation in standard form. Okay, for our next one, I want to compare these 2 graphs that you see here that I already drew out. The first one, there's a parabola and also a line, and on the second one, it's just a parabola. And the directions say they want us to find all the roots, and roots is the same thing as saying zeros, solutions, answers, so on and so on. But when you want to find the solutions, and there's 2 different graphs on the same grid, you want to look for where these 2 graphs intersect. So in this case, I have one right here, and I have one right there. So the solution when you have 2 of these is going to be where this line and this parabola intersect. So this green point looks to be at 4, 2, and this one over here would be at -1, -2. Now when I go to find the solutions on this one, I only have a parabola, so my solutions are where it crosses the x-axis, and in this case it would be at -3 and 3. So that would be -3, 0 and 3, 0. And that's why we call these the zeros, because it's where y is 0, which is what causes your graph to cross the x-axis. Okay, next we're going to look at solving a quadratic. So let's say that we have -5 is equal to, I don't know, 2x squared plus 7x. So if we want to solve this, and we're going to try using the quadratic formula, the first thing we need to do anytime we solve a quadratic is that we set the whole thing equal to 0. So to get rid of this negative 5, I bring it over. So now I can say that 0 is equal to 2x squared plus 7x plus 5. And now to use the quadratic formula, we make an A, B, C box, and I say, well, what do we have? A is 2, B is 7, C is 5. And I say, what is the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we start plugging stuff in. So negative b gives us negative 7 plus or minus the square root of b squared would be 7 squared, which is 49, minus 4 times a times c all over 2a. And a is 2, so 2 times a is 4. And then we keep going here to see what we can simplify. This becomes negative 7 plus or minus the square root of 49 minus, what do we get up here? 4 times 2 is 8, and 8 times 5 is 40. So this part up here was really 40. And 49 minus 40 is 9. And we put that over 4. And now I say, well, what else can I do with this? Well, the square root of 9, we know that, and the square root of 9 is 3. So negative 7 plus or minus 3 over 4. And then this breaks into two different problems. So what do we have? Negative 7 plus 3 over 4. Negative 7 minus 3 over 4. Doing our math, negative 7 plus 3 is negative 4. And negative 4 over 4 is really negative 1. Go to the other side. Negative 7 minus 3 is negative 10 over 4. And negative 10 over 4, when we simplify that, is really equal to, divide the top and bottom by 2. And that gives us negative 5 over 2. You could also call that negative 2.5. Okay, for the next part, we're going to look at what the discriminant is. And the discriminant tells us how many real answers there are to a quadratic. And the discriminant is the part you saw underneath the square root in the quadratic formula, the b squared minus 4ac. And when you run that, there's 3 different possible outcomes you can get. Whatever number you come up with, it could be positive, it could be negative, or it could be 0. If you come up with a positive answer, that means we have 2 real answers. If you come up with a negative number underneath the square root, for example, say, you have negative b, whatever that ended up being, and when you do your square root, say you have a negative number underneath that. Well, you can't take the square root of a negative, which means we're going to end up with an imaginary or an I somewhere, which means you would have 0 real answers. Again, the discriminant is just this part you see underneath the square root, but it affects the whole problem because it determines what happens in your quadratic formula. Say you get 0 underneath here. Well, if you have 0 underneath here, this would be negative b plus or minus the square root of 0 all over whatever 2a was. And if this is a 0, the square root of 0 goes away, and the only thing you're left with is negative b over 2a, which means you're just going to get one answer. So let's keep that in mind. I'm going to pull this off to the side. Let's try one. So let's say we have 2x squared is equal to 4x minus 7. And if I want to solve this or use the discriminant to figure this out, the first thing I need to do is recognize it is a quadratic. So I want to pull everything to the same side and set it equal to 0. So that's 2x squared minus 4x plus 7 is equal to 0. Okay. I know that my discriminant is b squared minus 4ac. So I'm going to make an ABC box here and say that a is 2, b is negative 4, and c is 7. So b squared would be 16 minus 4 times a times c. This becomes 16 minus 4 times 2 is 8, and 8 times 7 is 56. And then I'm looking at 16 minus 56 is a negative. You could stop right there. It doesn't matter what you get because it's a negative. It is negative 40 though, so if it's a negative, I come back here, and what happens when it's negative means I would have 0 real answers. So if we went through and we actually did the problem using the quadratic formula and we just wanted to solve it, we could keep going here. What would we know? The quadratic formula is negative b. Well, b is negative 4, so negative b is a positive 4 plus or minus the, we already solved this. This is the discriminant portion right here, which is what we just did right here, b squared minus 4ac. I know it's negative 40, so there we go, negative 40, all over 2a. Well, a is 2, so 2a is 4. Okay, so if we keep going here, what can I do with this square root? Pretend it was 40. Is there a perfect square that come out of there? We could say 4 times 10, and the square root of 4 is 2. And when I have this negative symbol, to get rid of this negative, I pull it out and make it an I. So this is really 4 plus or minus. This 40, again, we're making it 4 times 10, and the square root of 4 is 2. To get rid of this negative, I pull an I. I'm left with a 10, and I put this all over 4. And then you might be asking yourself, can I cancel these? To know if you can cancel these, you have to be able to make a nice little triangle here. And if this number on the bottom can reduce with this one and this one, then you can cancel. But if it only would work with one of them, then you wouldn't be able to. In this case, you can pull a 2 out of all these. And then you could say this is, if we divide them all by 2, 2 plus or minus I radical 10 over 2. Okay, the last part we're going to talk about for this video is end behavior. If you remember end behavior, we said it's a graph where stuff's going on in the middle, whatever. And I want to know what happens at the end of my graph on the right side. Does it go up or down? And on the left, is it going up or down? And the first thing we learned to do was a test. We said, as far as the right part of my graph is concerned, does it go up or down? And to figure that out, I look at the leading coefficient, which is the first number we see out front, and I ask myself, is that number positive or is that number negative? And if it's positive, the right goes up, or if it's negative, the right goes down. Then I want to find out what happens on the left side of the graph. To find that out, I look at the degree. And I ask myself, is the degree even or is the degree odd? And these two words help you see what's going on. If your degree is even, in other words, 2, 4, 6, 8, an even number, the left is equal to the right. Even, equal. If the degree is odd, 1, 3, 5, 7, whatever, the left does the opposite of the right. Odd, opposite. So the numbers, even and odd, they can kind of direct you in what you're doing here. So if we wanted to try an example here, let's say we had f of x is equal to, excuse me, negative 2x to the 4th minus 3x. First thing I want to do, I want to find the right. So I look at the leading coefficient. Is it positive or negative? And in this case, the leading coefficient is negative. That tells me that the right is going down. Then I want to look at the left. And the left, what do I see? Even. Even, equal. So the left does the same thing, and the left goes down. Now, this isn't how we write our answer, but this is how we find out the information. So, what would a graph look like where both the left and the right are going down? Kind of like a parabola that is flipped. So, what is the end behavior here now? So to do end behavior, how we want to write our answer out, here is the actual answer down here. We write our answer as x goes to infinity, f of x goes, this we've got to find out, and as x goes to negative infinity, f of x goes, so remember, f of x is another way of saying y, so I like to just put my pencil here right in the middle, and as x goes to infinity, where's infinity at? It's over here somewhere, right? Here's infinity. So as x is going this way, and remember x is your left and your right, and f of x, or y, is your up and your down. So as x is going all the way this way, where's my graph going? Up or down? It's going down. So in this case, it heads towards negative infinity. As x goes to negative infinity, again, x is my left and my right, so as x heads to negative infinity, where's my graph going? Up and down. It's heading down, so in this case, both of these would be negative infinity. Okay guys, that's as far as I'm going to go today with this video. If you need to rewind this and review any of them, feel free. If not, come up, take your 10-question quiz.